My name is Emiliano Jasso.
Nicolas, Mantilla. A function that is continuous is a function whose graph has no breaks in it.
Functions, however, will have isolated points where they are not connected. These problem points are called discontinuities. We will explain the four types of discontinuities.
Discontinuity is when the graph approaches a point but never touches the point. But because the function never touches the point, there is a discontinuity in the graph. In the function f of x equals 1 over x minus 1, we know that the domain is all real numbers, except 1. In the graph, it can be observed a vertical asymptote at x equals 1, which means that the function will never touch at any time x equals 1. It just approaches to infinite from the right and negative to the left. For this reason, it can be an infinite discontinuity.
In the function f of x equals x plus 4 divided by x minus 1 times x plus 8, we can see that the domain is all real numbers except minus 8 and 1. Okay, so we can see in the graph that the function behaves very strangely at the holes and at the asymptotes, as they never touch in those values, which in this case are minus 8 and 1. As we approach x equals 1 from the left side with increasing values, we can see that the y value drops lower to negative infinite. This represents a discontinuity since the function is not connected over the dotted line.
Removable discontinuity is a point on the graph that is undefined or does not fit in the rest of the graph. There is a gap at that location when you are looking at the graph. The graph has a hole at x equals 2, which makes the graph to make a jump and be discontinuous because it divides the function as observed.
To be 1 at the point x equals 3. Yet the rest of the function is dictated by f of x equals x squared. We can see in the graph that the function is continuous except for the tiny hole in the curve at x equals 3. It is discontinuous at this single point.
In child discontinuity are two separate functions, one that is defined for x less than or equal to 1 and another function that is defined for x greater than 1. Here we can observe how there is a jump at x equals minus 1. The graph jumps from y equals 0 to y equals 3. This is what makes the graph discontinuous.
Consider the function f of x equals x squared with a restriction of x being less than 1 and 6 minus x with a restriction of x greater than 1. In here, two pieces have a different value at x equals 1, as we can see. That our function f seems to jump from one branch to the other. Note that this jump makes the function discontinuous.
Notice that the x equals 0 is the left endpoint of the domain 0 to infinity, and it is not continuous because a limit does not exist.
Observe the graph f of x equals square root of x plus 1. In here, we can observe that the graph starts from this endpoint. It is not continuous as it only starts from the origin to the right, but not to the left.